Exercise 7.8, question 4. Integration 1 to 4 x square minus x dx. We have to find this definite integration using limit of sum. If I compare, then I will get a value of a as 1, b as 4, and my f of x will be x square minus x. We'll find the value of h by using formula b minus a upon n. So it will be 4 minus 1, 3 by n. I will also find a plus ih, f of a plus ih, that is f of 1 plus ih. Keeping the value in f of x, I will have 1 plus ih whole square minus 1 plus ih. So a square plus 2ab plus b square minus 1 minus ih plus 1 minus 1 will get cancelled out. 2ih minus ih will give me ih plus I square h square. Now integration 1 to 4 x square minus x dx can be written as limit h tends to 0 h sigma I1 to n f of a plus ih. Now I have the value of f of a plus ih. So we will keep that value in this limit h tends to 0 h sigma I1 to n f of a plus ih is ih plus I square h square. So we will give this sigma to each and individual term. H will come outside and I will have I1 to and I. H square will come out of sigma I square. Now we will replace the value of h. As you can see that h and n is having a reciprocal relation. So if h tends to 0, my n tends to infinity. 3 by n, 3 by n, and n plus 1 by 2. This is the formula of I. This will be 9 by n square, and n plus 1, 2n plus 1 by 6. Right. Here n n will get cancelled out. And I will have 3 by 2 n plus 1. Here 1n will get cancelled out and 1n left will go in this bracket n plus 1. And this will also will get cancelled. So 3 3s are 9, 3 2s are 6. So 3 by 2. This will be 1 plus 1 by n. Whereas this will be 2n plus 1 as it is. I can take 3 by 2 common outside from both of this. Then I will have 3 3s are 9 by 2. And I will take this n inside. So 1 plus 1 by n plus here it will be this n will divide with this second term to give 2 plus 1 by n. Right, as n tends to infinity, 1 by n tends to 0. So I will keep the value of 1 by n as 0. So 1 plus 2, this will give me 3, which will be 27 by 2. Right. Question 5. Integration minus 1 to 1 e raised to x dx. See, here till now we were having algebraic expressions. Now we got as exponential. Somewhat different approach we will apply over here. Here a is minus 1, b is 1, f of x is e raised to x. The value of h is b minus a upon n. minus a upon n. 1 minus minus 1 upon n will give me 2 by n. Here I will require the value of nh, which will be 2. Now f of a plus ih, that is f of 1 plus ih, will give me e raised to 1 plus ih. I can write this as e into e raised to ih, applying laws of indices. Right, now integration minus 1 to 1 e raised to x dx can be written as limit h tends to 0 h is sigma I1 to n f of a plus ih, that is limit h tends to 0 h is sigma I1 to n e into e raised to ih. Now as you can see that e is constant, will come out of limit h tends to 0 h. Now sigma will be given to e raised to ih. So if I give the value of I as 1, then I will have e raised to h, e raised to 2h, e raised to 3h, e raised to nh. As you can see that this is GB forming with a as e raised to h and common ratio as also e raised to h. And we also know the summation of GP as a into r raised to n minus 1 upon r minus 1. This is the summation of geometric progression. So a r raised to n minus 1 upon r minus 1. Now I will take this h in the denominator of e raised to h minus 1 because we have the formula for that. E raised to h as it is, this is e raised to nh, and the value of nh is 2 from equation 1. So I will keep nh as 2, mentioned from 1. Right, whereas this will be e raised to h minus 1 upon h. Now you can see that here I can apply this limit e raised to 0 e square minus 1 and e raised to h minus 1 upon h, limit x tends to 0 will give me 1. Right. So now e into 1 into e square minus 1 by 1. That is the final answer will be e cube minus e. This is my final answer. See, we did one mistake over here. We took a as 1, whereas a was minus 1. So if I keep on replacing the value, I will have e raised to minus 1. Right. So this will be e raised to minus 1. This will come out of this. See, this will be e raised to minus 1. So now if I see it, then this will be e raised to minus 1 multiplied by e raised to 2 will give me 2 minus 1 1, whereas e raised to minus 1 is e raised to minus 1, which can be simplified as e minus 1 by 2. Right. Now this is the correct answer. Earlier we did mistake, in place of a I have kept 1, but it should be minus 1. The value of a is minus 1. So we accordingly corrected our answer. Question 6. Integration 0 to 4. 0 to 4. x plus e raised to 2x dx. Here you can see that it is a combination of algebraic and exponential. A is 0, b is 4, f of x is x plus e raised to 2x. H is b minus a upon n, 4 minus 0 upon n. H is 4 by n also, and nh is 4 also. We will use both in our calculation. F of a plus ih will be f of 0 plus ih will be f of just ih will be ih plus e raised to 2ih. Integration 0 to 4 x plus e raised to 2x dx can be written as limit h tends to 0 h sigma I 1 to n f of a plus ih, keeping the value of f of a plus ih as ih plus e raised to 2ih. Now see, we will give this limit and sigma to both of this term and we'll solve individually because different approach is applied for both of them. So limit h tends to sigma I 1 to n. Limit h tends to 0 h sigma I 1 to n ih plus limited h tends to 0 h sigma I 1 to n e raised to 2ih. So here I will replace the value of h by n, and you know that h and n is having reciprocal relation. So n tends to infinity, 4 by n. H will come outside and sigma I 1 to n I. Here limit h tends to 0. H giving sigma, keeping the value of I as 1, then 2, then 3, and lastly n will give me this. Now as you can see that this is the geometric progression obtained with first term as e raised to 2h, our common ratio also as e raised to 2h, and we know that summation of geometric progression is a r raised to n minus 1 upon r minus. Limit n tends to infinity, 4 by n, and this is also 4 by n, and this will be n plus 1 by 2. Here limit h tends to 0, h a r raised to n minus 1 upon r minus 1. Right. Now, here n will get cancelled, 2 ones are 2 twos are. I will take this n inside. So, 4 bracket 2, 1 plus 1 by n. Right. Plus limit h tends to 0. I will take this h in the denominator of e raised to 2h minus 1. So e raised to 2h, e raised to 2nh. Now keeping the value of nh as 4 from equation 1, e raised to 2h minus this h as power of e is 2h. I will multiply 2 and will divide 2. And I will write it there from 1. Now I can keep 1 by n as 0. So 4 into 2, 1 plus 0, bracket over. Here also I will keep h is equal to 0, so e raised to 0, e raised to 8 minus 1 upon limit h tends to 0, or limit 2h tends to 0, e raised to 2h minus 1 upon 2h is 1. into 2. So finally, 4 2s are 8 plus e raised to 0 is 1. So e raised to 8 minus 1 upon 2. So if I take LCM, then I will have 16 minus 1. So e raised to 8. 16 minus 1 will give me 15 by 2. This is my final answer. So let's just start with exercise 7.9. First question. Here it is given integration minus 1 to 1 x plus 1 dx. So we'll just take a normal integration that we used to do in indefinite integration. Here we will apply the formula of x raised to n, which is x raised to n plus 1 upon n plus 1 plus integration of 1 is x. The limit is from minus 1 to 1. So first of all, we'll keep upper limit, that is 1, right? Then minus lower limit. So this will be 1 by 2 plus 1 minus 1 square is 1 by 2 plus minus minus and minus minus plus. So you can see that 1 by 2 will get cancelled out and your answer is 2. This is how we find definite integration. Question 2, integration 2 to 3 1 by x dx. We know that integration 1 by x dx is log mod x. We keep the limits. First of all, we'll keep x as 3, then minus. Now applying the property of log, you know that if two logs are in subtraction, then I can write it as common log as log 3 by 2. Third question, integration 1 to 2 4x cube minus 5x square plus 6x plus 9 dx. So 4 will come out of integration x raised to n plus 1 upon n plus 1, x raised to n plus 1 upon n plus 1, x raised to n plus 1 upon n plus 1. Integration dx is just x. We'll cancel the terms if it is possible. So here it is x raised to 4 minus 5 by 3x cube plus 3x square plus 9x. Now first of all, we'll keep the upper limit, that is 2 raised to 4 minus 5 by 3 to cube plus 3 to square minus, we'll keep the lower limit, 1 raised to 4 minus 5 by 3 1 cube plus 1 3 into 1 square 9 into 1, right? So 16 minus 40 by 3, 4 3s are 12, 18, 1 minus 5 by 3 plus 3 plus 9. So this is 30 and 46. 46 minus 40 by 3. And this is minus 13 plus 5 by 3. So if I solve this over here, then 46 minus 13 will give me 33, and this will give me minus 35 by 3. So 99 minus 35 by 3. 4. 64 by 3. This is my final answer. Let's continue with the fourth sum. Integration 0 to pi by 4 sine 2x dx. We know that the integration of sine is cos 2x, as the coefficient of x is 2, I have to divide 2. Right, we'll take minus 1 by 2 outside and we'll keep the value of x first as pi by 4 and then 0, upper limit and then lower limit. So this will be pi by 2, and you know that cos pi by 2 is 0, whereas cos 0 is 1. So I will get a minus 1. Answer is half. Integration 0 to pi by 2 cos 2x dx. Right, integration of cos is a sine, the coefficient of x is 2, we have to divide 0 to pi by 2. So we'll take 1 by 2 outside and we'll keep the value of x as pi by 2 first and then 0. Sin pi is 0, sin 0 is also 0. I will get our answer as 0. Integration 4 to 5 e raised to x dx. We know that integration e raised to x is e raised to x 4 to 5. First of all, I will keep the value of x as 5 and then I can write this as e raised to 4e minus 1. Question 7. Integration 0 to pi by 4 10x dx. Now we know that integration of nx is log mod sec x. We'll keep the value of x as pi by 4, then 0. This is root 2, whereas this is 1, and log 1 is 0. So final answer is log root 2. I know that I can write it as 2 raised to 1 by 2, and applying the property of log, I can take this in coefficient to write it as half log 2. Let's try to understand the 8th question. Integration pi by 6 to pi by 4 cosec x dx. We know that integration of cosec x is cosec x minus cot x, pi by 6 to pi by 4. We give the value of x as pi by 4 minus log this is log root 2 minus 1 minus log this is 2 minus root 3 plus that is bracket over. Now you can apply property of log, that is root 2 minus 1 divided by 2 minus root 3. That's it. This is your answer. Question 9. Integration 0 to 1 dx upon root 1 minus x square. This is of the form a square minus x square, that too in root. The answer for this is sine inverse x by a. As the value of a is 1, we will not write that. So first of all, we'll keep 1 and then 0. Sine inverse 1 is pi by 2, whereas 0 is 0. So answer is pi by 2. Then integration 0 to 1 dx upon 1 plus x square. This is 1 by a tan inverse x by a. We'll keep the value of x as 1 and then 0. Tan inverse 1 is 5 by 4, tan 0 is 0. So answer is 5 by 4. 11th question. 223 dx upon x square minus 1. So this is of the form x square minus a square, whose answer is 1 by 2 a log mod x minus a upon x plus a. So we'll take 1 by 2 outside and we'll keep the value of x as 3 minus so log 2 by 4 minus log 1 by 3. So this can be written as 2 by 4 divided by 1 by 3, that is multiplied by 3 by 1. So I can write this as log 3 by 2. So this is my final answer, 1 by 2 log 3 by 2. Let's start with the 12th question. Integration 0 to pi by 2 cos square x dx. Now I can write cos square as x as 1 plus cos 2x upon whole 2 dx. Now we'll take this 1 by 2 outside, and the integration of 1 is x, whereas integration of cos is sine 2x. As the coefficient of x is 2, I have to divide it. Right. We'll keep the value of x as pi by 2 first, and then 0. So pi by 2 plus this 2 will get cancelled out, and sine pi is 0, and sine 0 is also 0. So I will have my final answer as pi by 4. 13th question here will apply substitution, and how we can change the limits if we are applying substitution, that you will see. It is x dx upon x square plus 1. So here I will assume x square plus 1 as t. 2x dx will become dt. So x dx will be dt by 2. Now, if your value of x is 2, implies at that time t will be 2 square plus 1, which will be 5. And if the value of x is 3, then at that time the value of t will be 10. So now I will change my limits from 5 to 10, dt by 2 upon this is t. So 1 by 2 will come outside, integration 5 to 10, 1 by t dt, which is log mod t, and we'll keep the limits as 5 to 10. So we'll first keep the value of t as 10 and then 5. So applying property of log, I can write this as 10 by 5, which is log 2. This is my final answer.